Hello and welcome to my channel. In this math video tutorials, we want to solve this problem, and this problem is under binomial expansion. So we are to expand x plus 3 to the power of 4 using Pascal triangle, and I have done a video on Pascal triangle showing you how you can be able to get the triangular arrays of numbers, and then the application is what we're doing now. So if you do not have much idea about Pascal triangle, I will drop the link to that video in the description of this video. So consider watching the video. Go through the description. I will drop the link and then watch the video. It will help you a lot in gaining much understanding about this. However, I'm going to sketch up to the power of 4 of Pascal triangle in this video to enable you gain more understanding. So let's get into it. So what does Pascal triangle have? It has this expansion series to be, you have to start with 1, and this is for when you have a power of x plus, say, y to the power of 0. And of course, you know, anything to the power of 0 is 1. Then you always start with 1 and end with 1. And the whole process will look like a triangular array. So this is for x plus y up to the power of 1. You can also start with 1. When you add up 1 plus 1, that will give you 2. You end it with 1. And this is for x plus y to the power of 2. When you have the power of 2 expansion, this is what you will use. So you also start with 1, add up 1 plus 2, that will give 3. 2 plus 1, 3. You end it with 1. This is for when you have x plus y up to the power of 3. Keep in mind, you can use a plus b. You can use any of the variable you can think of. So here you can start with 1 because we are looking for the power of 4. So 1 plus 3 will be 4, 3 plus 3 will be 6, and 3 plus 1 will be 4, and 1. So this is where we're going to stop the expansion series because we need these coefficients, which is 1, 4, 6, 4, 1. All right. You know, ideally, if you're given this to expand, you want to say x plus 3 all to the power of 4 is equal to, and this means that you need to bring out about 4 of this x plus 3. You know, when you're expanding it, you have to duplicate it. For those of you who have done algebraic expansion, this should be the result of what you want to do. And then after which, you use this to multiply by this. When you get the result, you use the result against this, and you can see how strenuous that could be. That's the reason for this expansion. Pascal introduced these arrays that you can be able to use in simplifying this problem just in 1 or 2 lines. You're already there. All right, so let's get started. So we have for this problem x plus 3 all to the power of 4. We have the coefficient to be 1, 4, 6, 4, and 1. All right, so what do we do? Look at the simple trick or the simple pattern I like students to engage in. I'll just use this one. This one is representing this x, the coefficient of this x. This 3 is for this 1 is for this 3. So just take it that the first one you're having is for the first term. The last one you're having is for this alone. But these ones can go for the 2 of them. So look at how I'm going to apply it. I will say 1 times x, and that will give me x. And I will raise it to the power of 4. Keep in mind what you should be doing. You're going to use your hand to fill it. The power of this x will be reducing. It will reduce from this 4 to 0. Whereas the other power, the power of this 3 will be increasing. Power of x will be decreasing. Power of 3 will be increasing. Watch how I'm going to do it. 1 times x is x to the power of 4 plus, this time is about 4. 4 multiplied by x and 3 will be 4 multiplied by x and also multiplied by 3. All right, this x power is 4. So at this point, it will reduce to 3. You're going to fix it by yourself. All right, and then 3 now started the joining, which is 1. All right, so plus the next number is 6. So it's going to be 6 multiplies by x and also multiplies by 3. And when you do this, remember that x here was 3 to the power, so here it will reduce to 2. And then for 3, the power increases to 2 from 1. So plus, what's the next thing? 4. 4 number. This 4 is going to multiply by x and also multiply by that 3 over there. So x will reduce from, the power of x will reduce from 2 to 1. And then that of 3 will increase from 2 to 3. I hope you're catching the flow. Alright. Plus, the last one is this one. 1 times 3 is 3, and 3 to the power of 4. So we have 3 to the power of 4. If you want to put it in brackets, it's not a problem. Alright, it's a positive integer, so it will still give you a positive value. Alright, I hope you like this arrangement. And then the next point you want to do is to expand to get your final answer. X to the power of 4 remains like that, plus, so let's multiply this through. You know, x to the power of 3 remains x to the power of 3. 3 to the power of 1 is 3. 3 times 4 will give you 12. So you have 12 x to the power of 3. Alright, plus this 3 to the power of 2 will give you 9. And then you multiply 9 by 6, and that will give you about, I think that's 54, thereabout. Maybe you could check while you are writing it down with your calculator. So this have x to the power of 2 will remain, plus 3 to the power of 3 will give you 27. 3 times 3 is 9. 9 times 3 is 27. And 27 times 4 should be about 108. 108. Then x to the power of 3. Then plus the last one, which is 3 to the power of 4. 3 times 3 is 9, times 3, 27. And 27 times 3, that's 81. 81. Now carefully check the power. You can see that x to the power of 4 reduces to x to the power of 3, x to the power of 2, x to the power of 2, and here, sorry, here is 1, x to the power of 1. It's a slip of pen. Alright, so it reduces to x to the power of 1. And then we have to, another one to maybe x to the power of 0, which is not necessary. Here too, we're supposed to have 3 to the power of 0, which is not necessary. So this is the answer to this expansion. You can see the power of x decreasing from 4, 3, 2 to 1. And then this is the value or the expansion series we are looking for. And we have 1, 2, 3, 4, 5. If you are asked to find the 5th term or maybe the 3rd term of this expansion, then this is the 1st term, 2nd term, 3rd term. You just stop here. But here they didn't specify whether we need the 5th term or just this simple expansion for this. And then I hope you found this video helpful. Please consider subscribing to my YouTube channel, because it will help me a lot to grow the channel. And also consider liking the video and share to your learned colleague. If you share it to your friends, they'll be grateful that you made them see this video and also learn from it. And I would like you to also hit the notification bell so that when I upload a new video, you get notified, because I'm going to be solving more complex problem on this Pascal Triangle and binomial theorem. Thank you for watching. I'll see you in the next video.